Hello everyone, I hope you guys are doing extremely well. Today we are going to discuss another problem in our binary search tree series. The problem name is max value in a BST. So let us understand the problem description first. So we are given the root node of a binary search tree and we want to find the maximum value in that binary search tree. So the problem statement is pretty clear, but let us take an example to understand it more clearly. Let us say the root node of the binary search tree given to us is node 35. Now the left child of node 35 is, let's say, node 25, and the right child of node 35 is node 45. Now for node 25, the left child, let us say we have is node 15 and the right child is node 30. Now for node 45, let us say the left child is node 40 and the right child is node 55. Now the left child of node 15, the left child of node 15 is null, the right child of node 15 is null, the left and right child of node 30 is also null. Similarly for node 40. Now for node 55, the left child is null but the right child is node 65. Now we want to find the maximum value present in this binary search tree. So what is the maximum value present in this binary search tree? We can clearly see the maximum value present in this binary search tree is node 65. So what we are going to do, we are just simply going to return the value of this node 65. So 65 will be our answer, and we can clearly see this, that node 65 is nothing but the rightmost node, the rightmost leaf node. So this problem can be related to the previous problem. In the previous problem we have tried to find the minimum value node. In this problem we are trying to find the maximum value node. So how can we do that? We can simply go to the right subtree of every node, and at the end the rightmost node will be our answer. So let us take one more example to understand this in depth. So let us say the root node given to us is node 38. Now the left child of node 38 is, let's say, node 28 and the right child is, let's say, node 48. Now for node 28, let us say the left child is node 18 and the right child is node 30. Now for node 48, let us say the left child is null and the right child is node 58. Now the left child and the right child of node 18 and node 30 is null. Now for node 15, let us say the left child is nothing but node 50 and the right child is nothing but node 68. Now for node 68, the left child is null and the right child is node 78. So how can we solve this problem? So we can simply start from our root node and we will check whether there is any right subtree for node 38. So for node 38, we can clearly see that yes, there is a right subtree. So we'll reach at node 48. Now for node 48, again we are going to check, is there any right subtree for node 48? So yes, there is a right subtree for node 48 and we'll reach at node 58. So for node 58, again we are going to check, is there any right subtree for node 58? So yes, there is a right subtree for node 58 and that is node 68. So we'll reach at node 68. Now for node 68, we are again going to check, is there any right subtree for node 68? Yes, there is a right subtree for node 68 and that is node 78. Now is there any right subtree for node 78? There is no right subtree for node 78. That means this node 78 value is our answer. So what we have done, we have started from the root node and we moved on to the left subtree until we hit null. So we have started from here and we reached to node 48 first, then from node 48 we reached to node 58, then from node 58 we reached to node 68, and then from node 68 we reached to node 78. Talking about the time complexity of the approach, the time complexity of this approach is big O of log n, and the space complexity is also big O of log n if we are using recursion, and if we are using iteration then it will be big O of 1. N is nothing but the number of nodes present in this binary search tree. Why big O of log n? Because at every point we are eradicating an entire left subtree. Therefore the possibilities left to us will be only in terms of log n. Okay, now these type complexities are space complexities when we are handling the average case. Now what will happen if we are handling a worst case? So let us understand our approach in the worst case as well. So let us say we are given the root of the binary tree as node 45. The left child of node 45 is, let's say, node 55, and the right there is no less, sorry, okay, node 45 is the root node of the binary search tree. Now the left child of node 45 is null and the right child is node 55. Now the left child of node 55 is null and the right child is node 65. Now the left child of node 65 is null and the right child is node 75. Now the left child of node 75 is null and the right child is node 85. We want to find the maximum value node. So how can we do that? We will start from the root node. So we are going to start from the node 45 and we are going to check, is there any right subtree for node 45? So yes, there is a right subtree. So we'll reach at node 55. For node 55, we'll again check, is there any right subtree for node 55? Yes, there is a right subtree for node 55. So we'll reach at node 65. For node 65, is there a right subtree? So yes, there is a right subtree. So we'll reach at node 75. For node 75, is there a right subtree? So yes, there is a right subtree. So we'll reach at node 85. Now for node 85, is there a right subtree? There is no right subtree for node 85. So what we are going to do, we are simply going to return the value of this node. So we'll simply return 85. So what we have done, we have started from the root node, we reached on to node 55, that is its right subtree. From node 55, we have reached its right subtree. So we reached to 65. From node 65, we reached its right subtree. So we reached to 75. From 75, we reached its right subtree. So we reached at 85 and that's it. 85 has no right subtree. So it is our final answer. Now talking about the time complexity, in the worst case, it will be big O of n, where n is the number of nodes present in BST. Why big O of n? Because we are going to iterate all the nodes. We are iterating all the nodes, and whenever we are going to iterate all the nodes, the time complexity will be big O of n. Talking about the space complexity, the space complexity will be big O of n if we are using recursion to solve this problem, or if we are using iteration, it will be big O of 1. Fine. Now when will the worst case arise? The worst case will arise when we will have a degenerate or a pathological tree. That is, every node is gonna have only one children. I hope the solution approach made sense to you guys. The problem was pretty easy. So now we are going to understand how we can convert our logic in the form of code. So let's do that as well. So as you can clearly see, I have already declared a function called max value. This max value is taking the root node as an argument. This root node is nothing but an object of class tree node. Okay, this class tree node is having a constructor. I have already told you in the previous videos that this class tree node is having a constructor that is initializing the value of the node. The left and the right subtree by default is set as null. Okay, now what is the first thing that we need to do? First thing, we are going to initialize a variable called current. So current will be initialized with root. Now till the point this current is having a right subtree, we are going to move in the right. So while current dot right is not null, that means current dot right, that means current is having a right subtree. So we are going to update our current as current dot right, and in the end our current is gonna point to the rightmost node. So we are just going to return current dot val, and that's it. That's all the code that we needed to do. So let us take an example to run our code as well. We are given the root node as node 25. Now the left child of node 25 is, let's say, node 15, and the right child is node 35. Okay, sorry, I'm gonna take a small example so that I can run my code. So the right child of node 35, that is root dot right will be nothing but node 45. So let's call this function max value and pass the root node, that is 35. So let's give this function a run and let us check. Sorry, not 35, we need to pass the root node. So let's give this function a run and let's check the output of our code. So the output of our code is coming out to be 45, which is correct because 45 is the maximum value. Okay, I hope the code made sense to you guys as well. If you guys still have any queries regarding this problem, please drop your concern in the comment section and I will be more than happy to help you there. Regarding this series, I will be uploading more of the questions in the upcoming weeks, so keep following us. Until then, keep smiling and keep coding. Thank you.